All right, this is section 3.1, working with complex numbers. He's asking us, number one, express the number, in terms of I. All right, so you would think maybe you could use your calculator, but what your calculator is going to do is change the any radicals that you may have into decimals, and you see there's no decimals here, so we have to do this manually. So number one, we've got the square root of a negative 5. And I'm hoping this is going to be dark enough. Let me see if I can darken this up a little bit. Yeah, it looks a little better. All right, so I'm going to express this as the square root of a negative 1 times a positive 5. All right, then I'll separate these into their separate radical symbols, and I realize that the square root of negative 1 is the letter I, so this is I radical 5. Now, as I look at my answers, I don't see I radical 5, but I do see 5 radical 5I. And what he's done is just interchange these two terms, right? Because multiplication is commutative. All right, radical 5I. And the I is not under the radical symbol, so we've got letter A correct. Number two, square root of a negative 25. Once again, I want to express this as negative 25 as a square root of negative 1 times 25, or negative 25 is negative 1 times 25. Separate these two under their own separate radical symbols. We know that the square root of negative 1 is defined as I. 25 is a perfect square. It's the whole number 5, so I'm going to interchange these two and write this as 5I, letter D. 5I. Number three, if I can slide this up a little bit. Number three here, what do we got? The square root of a negative 28. So I want to express this as negative 28 as the product of negative 1 and 28. But what I realize here, before I even go any further, is that 28 is not a perfect square, but there's a factor of 28, 4, that is a perfect square. So I'm going to write this as the square root of negative 1 times, now I want to express 28 as 4 times 7, and I'll write these under their separate radical symbols. So this will be the square of negative 1 times the square root of 4 times the square root of 7. Well, square root of negative 1 is I. 4 is a perfect square. It's equal to the whole number 2 times radical 7. So I'm rearranging these because multiplication is commutative. 2I radical 7. And what I see here with number 3 is he likes putting the I in back of the radical. He's written this as 2 radical 7I. I prefer it that way, but the answer sheet wants to give it to me this way, so we'll go with the flow. All right, 2I radical 7 can be written as 2 radical 7I. Multiplication is commutative. Obviously, it wasn't negative, and it wasn't anything to do with 14, and I don't know how he's getting 7 out. He'd have to have 49 under the radical to get a 7, so some crazy answers there. All right, number 4, he wants me to write my answer in the format of A plus BI. But, you know, what I've told you before, when you're dealing with addition, subtraction, multiplication, and even division, you treat I like any other variable, especially in addition and subtraction. You combine like terms. So what do I see here? A negative 5 and a positive 11. That's a positive 6. So I already know that C and D are out of the... because of the fact that a negative 5 and 11 is a positive 6. I see positive 6 here. Positive 6I added with 2 more I. Well, that's 8I. Alright, so this is fairly simplistic. Number 4, letter A. 6 plus 8I. And once again, I can do the same thing, combining like terms. I got a negative 5 and a positive 9. That's 4. So I see 4 here. I see 4 there. I don't see 4 in letter B or letter D. Let's see, a negative 6I combined with a positive 4I. That's going to be 2I. So where are we? Number 5. 4 minus 2i. Now, if I were to, here I'm just kind of doing it off the top of my head, but let's assume that we wrote it all out. Alright, so I could drop my parentheses. A plus sign preceding a parenthesis does nothing. And if I put my like terms together here, I could put my constants, negative 5 plus 9 minus 6i plus 4i. Let's see, negative 5 and 9 is 4, a minus, and the positive difference is 2. This is bigger, so it's negative 2i. So there I am doing it all out. Alright, but here again, it's almost like you could do it, I don't want to say do it in your head because I kind of go against that, but here's a case where you get the choice. And here again, I'm going to just look at this here. 5 and 4 more, it's 9. Alright, so I see 3 answers that have 9. Can't be letter C. A minus 8i added with a minus 2i is a minus 10i. Alright, so that's pretty easy. A minus 8 and minus 2 is a minus 10, so not much going on there. Number 7. Likewise, yeah, you could write it all out, but hey. 6 plus 2 more, that's 8. So I see 8 in letter A and letter B. That says negative 8, that says negative 8. Let's see, minus 3i combined. A minus 3i combined with 7i. Signs are alike, difference is 4, it's positive. So number 7 is 8 plus 4i. A minus 3 combined with a positive 7 is a plus 4i, letter B. Alright, here's one where I probably would write it out because of this minus sign that's going to affect both the signs in there. So this is number 8, sort of I got here. 12 plus 9i and minus 1 plus 3i. Alright, so dropping the parentheses. A minus times the terms inside changes the sign. This positive, which is understood, becomes a negative. This positive also becomes a negative. Combining like terms, 12 minus 1 plus 9i minus 3i. Well, 12 minus 1 is 11. Positive 9i combined with a minus 3i, difference is 6, and it's positive. 11 plus 6i. 11 plus 6i, and this is number 8, letter C. And once again, number 9, pretty much the same thing because of the fact you've got this minus sign here. So if I write this as 14 plus 8i, all you're doing is combining like terms. That's the size of it here, the long and the short. You're treating the I just like you would any other variable in algebra. Alright, 14 plus 8i. The minus sign changes the signs. This positive understood positive becomes a negative. That positive becomes a negative. Let's see, 14 minus 5, that's 9. 8i combined with a minus 2i is a positive 6i. 9 plus 6i. 9 plus 6i. Number 9, our favorite letter C. Number 10. Number 10, we've got minus 6, minus 6i. Minus 5, minus I. So dropping this first parenthesis, changing the signs of both these two terms. This understood positive becomes a negative. The negative becomes a positive. A minus 6 combined with a minus 5 is a minus 11. A minus 6 plus 1 more I. Signs are like, difference is 5, and it's negative. Minus 11. Minus 5i, minus 11, minus 5i, letter B. Alright, so from here on in, I'm going to let the calculator do everything. Could I do it manually? Yeah, but if we've got a calculator, why not use it? Could I use my calculator to combine like stuff here? Yeah, but it's overkill. Yeah, you could have done it, but combining like terms, I mean, it's by the time you write the thing out on your calculator, you could have done it in your head just about. So 11 and 12, 13. However, let me just do this. Let me just kind of jump down to numbers 19, 20, and 21. Now, in the PowerPoint, I showed you how to use your calculator, and I will do these, but we know this. We know that I is defined as I to the first is the square root of -1. I to the second is -1. I to the third is -I, and I to the fourth is a +1. All right, +1. So, and it repeats itself. I to the fifth goes back to I to the sixth is I to the second, which is -1. So here he's asking me I to the fourth. Well, we know by definition I to the fourth is a +1, so that's not a big issue. Letter D for number 19. Now what about I to the 21st? Here's what I tell people to do. Take 21. Since this thing repeats itself, the I values repeat themselves every 4 times. I'm going to divide 21 by 4. And I get a remainder of 1. That tells me my answer here is I to the 1 power, which is just plain old I. Alright, you could do this in your calculator, and I will, but it gives you this answer that has a plus or a minus sign, and one portion of it has this letter E, and you have to discount that. So another way of doing it, probably even a simpler way of doing it. Alright, so I to the 21st is just the letter I, which is letter D. I to the 14th. I to the 14th. I'm going to take the exponent and divide it by 4, since I repeats itself every 4 times. This is 3, this is 12. I get a remainder of 2. That tells me my answer is I squared. But what is I squared? I squared is a -1. Alright, the remainder that you had here was 2, which is telling me the answer is I to the 2 power. But what is I to the 2 power? It's -1. -1, which is letter A. That's the quick way of determining that, but I'll do this on a calculator and reiterate how you discount the part that has the letter E in it. Multiple ways of getting to the same answer, which is kind of nice.